From sweetening coffee in Vietnam to making key lime pie in Florida, condensed and evaporated milk are kitchen staples all over the world. It's a massive global market, projected to be worth over $11.8 billion by 2026. But have you ever really thought about what it is? How does fresh, perishable milk from a farm get transformed into a thick, sweet liquid that can sit on a shelf for years? The whole process is a wild journey of science and engineering that happens inside massive, high-tech factories. Today, we're going inside to see exactly how it's done. You'll see the entire process, from the automated milking parlors all the way to the perfectly sealed cans rolling off the line. We're going to uncover the science, the scale, and the clever engineering it takes to turn millions of gallons of milk into the creamy, golden liquid that fills billions of cans every year. Chapter 1. The source: modern dairy, high-tech milk. The story of condensed milk starts on a modern dairy farm, which looks a lot different than the rustic farms you might imagine. Here, it's all about technology, hygiene, and happy cows. The stars of the show are high-yield breeds like Holstein Friesians, and they're treated like professional athletes. Their diets are fine-tuned by nutritionists, and their living spaces are kept spotlessly clean to ensure they stay healthy. The milking process itself is a marvel of automation. Instead of a farmer with a pail, picture a rotating platform called a circular milking machine. The cows line up and automated units gently attach, mimicking the natural feel of a calf. This system is not only efficient, but it's also smart. Sensors know exactly when to detach to prevent over-milking, which keeps the cows comfortable and healthy. As soon as the milk is collected, it's piped directly into refrigerated tanks and rapidly chilled to about 2 to 4 degrees Celsius. This cold shock is critical. It stops bacteria from growing and preserves the milk's freshness. Before it even leaves the farm, the milk is tested for things like fat content and bacteria levels. Only the best of the best makes the cut. It's also important to know that not all condensed milk starts this way. Many modern factories, to ensure year-round consistency and efficiency, create milk by recombining high-quality skim milk powder and butter oil with purified water, a process that yields a perfectly standardized base to work from. Chapter 2. The journey to the factory, a race against time. Once the milk is approved, the clock is ticking. Getting it from the farm to the factory is a high-stakes race to keep it pristine. A fleet of specialized insulated tanker trucks, which are basically refrigerators on wheels, takes on the job. These food-grade stainless steel tankers are sterilized before every single pickup to prevent contamination. When a tanker arrives at the factory, it pulls into a reception bay for another round of intense quality control. Technicians in lab coats take samples straight from the truck. These samples are rushed to an on-site lab where a battery of tests checks for everything from fat and protein levels to bacteria counts. They use methods like the Resazarin test, where a dye changes color to reveal the microbiological quality of the milk. More advanced tools like mass spectrometry scan for any unwanted chemical residues like antibiotics or pesticides. Only after the milk passes every single test is it finally given the green light to be pumped into the factory's giant, refrigerated silos. Chapter 3. Purification and Standardization. Prepping for the transformation. Inside the factory, the first order of business is to make the milk even cleaner. It's sent through a series of fine filters and clarifiers. These machines use centrifugal force to spin the milk at high speeds, pulling out any microscopic impurities that might have slipped through. Next up is heat treatment. This step is designed to kill any harmful microorganisms and deactivate enzymes that could cause spoilage later on. In modern factories, this often involves heating the milk to a high temperature, around 100 to 120 degrees Celsius, for about a minute before the evaporation stage. This intense heat ensures the milk is safe and stable for the next steps. After the heat treatment, the milk is standardized. To get that perfectly consistent taste and texture every time, the factory needs to control the exact ratio of fat to other milk solids. A high-speed centrifugal separator spins the milk, separating the lighter cream from the heavier skim milk. These are stored in separate tanks. Then, like a master chef, an automated system blends the cream and skim milk back together in precise amounts to create a standardized milk that has the exact fat content needed for the final product. Chapter 4. The heart of the process. Vacuum evaporation. This is where condensed milk gets its name. The goal is to remove about 60% of the water from the milk, concentrating it into a thicker liquid. You can't just boil it in an open pot. That would scorch the sugars and ruin the flavor. So, factories use a brilliant piece of physics: vacuum evaporation. Here's the trick: a liquid's boiling point depends on air pressure. By reducing the pressure, you can make water boil at a much lower temperature. The standardized milk is pumped into a massive, multi-story vacuum evaporator. Inside, under a partial vacuum, the milk can be brought to a gentle boil at a cool 55 to 70 degrees Celsius. This low temperature allows water to evaporate efficiently without ever scorching the milk. Most modern plants use what's called a multiple effect falling film evaporator. The milk flows down the inside of long, heated tubes as a thin film, which creates a huge surface area for fast evaporation. The multiple effect part is an ingenious energy-saving design. The hot vapor created in the first chamber is used to heat the milk in the second chamber, which is held at an even lower pressure. This cascade continues, recycling energy down the line. Some systems even use mechanical vapor recompression, MVR, where the vapor is compressed to raise its temperature and then used to heat the evaporator, cutting energy use by up to 60%. Throughout this entire process, sensors constantly monitor the milk's density, ensuring that what comes out is perfectly concentrated. Chapter 5. The sweetening and preservation. A tale of two milks. Coming out of the evaporator, the concentrated milk is at a fork in the road. Will it become sweet and syrupy or rich and unsweetened? For sweetened condensed milk, sugar is everything. It's not just for flavor, it's the preservative. In many modern processes, a precisely calculated amount of sugar is actually added to the milk before or during the evaporation stage to make the process more efficient. The goal is to get the final sugar concentration to about 45 to 48% of the total product. This super high concentration creates intense osmotic pressure. Essentially, it binds up all the available water, and any bacteria or mold that falls in is instantly dehydrated and can't survive. This is why a can of sweetened condensed milk can last for years without refrigeration. For unsweetened evaporated milk, there's no sugar to act as a preservative. So, it needs a different approach. The intense heat of sterilization, which happens later, can cause the milk proteins to curdle. To prevent this, small amounts of food-grade stabilizing salts, like disodium phosphate, are added. These salts adjust the milk's chemistry, just enough to help the protein stay smooth and stable during the final heating process. Chapter 6. Achieving the perfect texture, homogenization and crystallization. At this point, the milk is concentrated, but the texture isn't locked in yet. If left alone, the fat globules would rise and form a layer of cream on top. To prevent this, the milk goes through a process called homogenization. A powerful pump forces the milk through a tiny valve at extremely high pressure. The shear force shatters the fat globules into microscopic droplets, which get evenly dispersed throughout the milk. This ensures a permanently smooth, uniform texture from the first drop to the last. After homogenization, the milk needs to be cooled, and for sweetened condensed milk, this step is critical for achieving its signature velvety texture. The enemy here is lactose or milk sugar. If cooled too slowly, the lactose will form large, gritty crystals, making the product feel sandy. To avoid this, factories use a technique called seeding. The warm milk is flash-cooled to around 35 degrees Celsius. Then, a tiny amount of finely powdered lactose crystals is added. These seed crystals encourage the milk's lactose to form millions of microscopic crystals instead of a few large ones. After seeding, the milk is cooled again down to about 15 degrees Celsius, locking in that perfectly smooth, thick body without any graininess. Chapter 7. The Final Frontier: Packaging, Sterilization, and Labeling. The milk is finally ready to be sealed away. It's sent to a high-speed automated packaging line. For the classic steel can, rows of empty, sterilized cans are fed into a rotary filling machine. In a perfectly synchronized dance, nozzles descend and dispense the exact amount of condensed milk into each can. A sterilized lid is immediately placed on top and hermetically sealed, locking out oxygen and contaminants. Here, the paths of the two milks split for the last time. Sweetened condensed milk is already preserved by its sugar, so it's ready to go. But the cans of unsweetened evaporated milk need one final step: terminal sterilization. The sealed cans move into a huge industrial autoclave, which is basically a giant pressure cooker. They are heated with high-pressure steam to about 115 to 120 degrees Celsius for 15 to 20 minutes. This intense heat sterilizes the milk inside, making it commercially sterile and safe for years. An alternative for evaporated milk is UHT, ultra-high temperature, processing with aseptic packaging. Here, the milk is sterilized before packaging by flash heating it to around 140 degrees Celsius for a few seconds. This sterile milk is then filled into pre-sterilized cartons in a completely sterile environment. Finally, the finished cans or cartons move to the labeling station, where machines apply branded labels with incredible speed and precision. From there, they are packed into cases, stacked onto pallets by robots, and shipped out to warehouses, eventually landing on a store shelf near you. So, from a high-tech farm to a gleaming factory, the transformation of milk into this pantry staple is an amazing feat of science and automation. It's a process driven by an obsession with hygiene and a deep understanding of food chemistry. The next time you open a can to bake a cake or sweeten your drink, you'll know the incredible story of innovation packed into every single drop. If you thought this journey was fascinating, make sure to like and subscribe for more deep dives into how the things we use every day are made. Let us know in the comments what we should explore next. Thanks for watching.